Hi, my name is Demi Padilla,
And my name is Mirna Beshai.
and this is our project, Cats Protecting Birds, Modeling the Mesopredator Release Effects. The Mesopredator release effect is a phenomenon which the population of medium-sized predators rapidly increase in ecosystems after removal of larger top carnivores. In terms of the study Cats Protecting Birds, Modeling the Mesopredator Release Effect, the superpredator will be the cat, mesopredators are rats, and the prey are the birds. So what this means to the prey is by introducing cats into an ecosystem where birds are preyed upon by rats, cats are protecting the lowest prey, the rats, by removing more of its predators. Although cats will still be preying on the birds, removing rats from the equations allows for the birds to be more copious in the environment with a decreased threat coming from the rats. What this means for the mesopredator, though, the rats, is that they're the dependent variable. When the superpredator is present, the mesopredator population decreases. When the superpredator is removed, the mesopredator hunts more, thus has a larger population, and by extension, less prey to consume. So that means that there'll be less birds. Why is this important? Is that some arguments state that removing a superpredator from an ecosystem can sustain a dwindling prey population. However, this model shows that that theory is incorrect because removing superpredators can have the opposite effect, meaning that there'll be less birds all around if you remove the cats. So these are the equations that we're using. Equation 1 and 2 models the prey mesopredator system. So this is how the prey and the mesopredator bird rat reacts. And this one, equations 3 and 4, is the system with the birds and the cats. We'll be modeling some of those. The mesopredator rate and the mesopredator on the prey is these equations. Equation 5 is what we're going to be modeling. It's going to be whenever the birds, the rats, and the cats are all present. These are the equations that show that, like the effect of that. We were also given these models on how they connect. Just as we said, that the superpredator is the cat, mesopredator is the bird, the prey is, or the mesopredator is the rat, sorry, and the bird is the prey. So the rats are preying on the birds, and the cat is the rat and the bird. And these are the models that they gave us. D is the one that we are going to be showing, and this is how each species interacts with each other.
Okay, so now we're going to be talking about the MATLAB and Simulink data that we produced. So we will be modeling one of the equations, which is equation 5, and we're going to be proving the data that the study has already shown us. So I chose to use coding to define the parameters because it made it easier to change the parameters in the model. And then for the Simulink model, first I created the 3 integrators, and then I put the addition signs before them. The first integrator was for B, the second was for R, and the third was for C. And then using the equations and the terms, I divided produced and added the blocks to get the signals I wanted. And then that gave us this graph, which does agree with the data, because we can see that when the mesopredator and the superpredator populations went up, we can see that the prey population went down. And that's all we have for our presentation. Thank you for listening.
Can you end the recording?